Hello friends, I am Professor Sunil Bairagi from Kekewa College of Agriculture, Nasik. So now our today's topic that is quality of irrigation water and the management of saline water for irrigation. So in this chapter we have seen the introduction, criteria to determine different parameters, then management of saline water, and then question and some reference we are using for this chapter. Then in introduction part, the suitability of irrigation water is mainly depends on the amounts and types of salts present in water. So if we are seeing the irrigation water, so while we are considering the suitability of water, for the suitability purpose, we have to know which are the types of salts or ions which are present in this irrigation water. For that purpose, we have carried out the analysis of this irrigation water. The main soluble constituents are calcium, magnesium, sodium as cations, and chlorides, sulfate, bicarbonates as anions. Okay, so mainly in cations there is a calcium, magnesium, and sodium. While we are considering the anions, that chloride, sulfates, and bicarbonates are present. The other ions are present in minute quantities are boron, selenium, molybdenum, and fluoride, which are harmful to animals fed on plant grounds with the excess concentration of these ions. So basically, if you have seen the boron, selenium, molybdenum may be occur in a smaller quantity, but they may impact on the animal health or human health. So irrigation water quality criteria. Water quality is determined according to the purpose for which it will be used. For irrigation water, the usual criteria include salinity, sodicity, and then ion toxicities. So mainly we are work criteria we are using, that means for the salinity hazard, sodium hazard, salt index, alkalinity hazard, permeability hazard, and then last one that is specific ion toxicity hazard. So for in using this, we are evaluating the quality of irrigation water, whether it is safe or good or bad for the irrigation purpose. Then salinity hazard. The concentration of soluble salts in irrigation water can be classified in terms of electrical conductivity, that means EC, and expressed as decisimon per meter. There is a four types of salinity. First one that is C1, C2, C3, and C4. Okay, so the classes C1 and C2 of water are considered suitable for irrigation purpose. Okay, that means it is having no problem. And while C3 and C4 classes of water are not suitable for the irrigation purpose. Okay, so that's why the C3 and C4 are having severe problems. That's why it is not suitable for irrigation purpose or recommended for irrigation. So the water class that is having low salinity, that means the EC is between 0 to 0.25 decisimon per meter. It can be used safely. Then medium right from 0.25 to 0.75. Then high salinity is around 0.75 to 2.5, and more than 2.25 if if the irrigation water having EC more than 2.25, it cannot be used for irrigation purpose. That means it is having very high salinity. So the sodicity hazard. High concentration of sodium are undesirable in water because sodium adsorbs onto the soil cations exchange sites, causing soil aggregates to break down, or we call as a deflocculation. Okay, so mainly remember the sodium is called as a dispersing agent. Okay, or we are also called as a deflocculating agent. So while we are considering the sodium, if it is a maximum concentration in the irrigation water, it may causing the soil aggregates to break down. That means a deflocculation, sealing the pores of the soil and making it impermeable to water flow. Okay, while sealing the pores of the upper surface of the soil, it making impermeable to water flow. Okay, so these all the seals, or so all the pores, that means macropore and micropores, are sealed with these sodium ions. That's why the water are also not permeable. Then the sodicity hazard of irrigation water is usually evaluated by sodium adsorption ratio, that is we are called as a SAR, the adjusted sodium absorption ratio, then sodium to calcium activity ratio, that we are known as a SCAR, then sodium ratio, then figure of merit. So first one, that is sodium adsorption ratio. United States Salinity Laboratory staff introduced the concept of sodium adsorption ratio. Okay, so sodium adsorption ratio we are measuring by sodium. The formula, that is SAR is equal to sodium upon square root of calcium plus magnesium upon 2. The sodium hazard of irrigation water expressed through SAR. It is also having 4 classes, that is S1, S2, S3 and S4. So for the S1 classes, that means low sodium hazard, the SAR value should be between 0 to 10. Okay, and while we are considering the medium, then high and very high, the SAR value is between the 10 to 18, 18 to 16, 26. And if the value of SAR, that means sodium adsorption ratio, is more than 26, the water is unsatisfactory. Okay, or this may be not recommended for the irrigation. Then sodium to calcium activity ratio. The application of sodium adsorption ratio to the group of water which have EC more than 5 decisimon per meter and magnesium calcium ratio is more than 1 is obviously questionable. For the groundwater having EC more than 5 decisimon per meter and dominance of magnesium over calcium, the SAR value should be calculated as sodium upon V plus calcium plus 2. Okay, so the classification of SAR or SCAR ratio was given by Gupta, and the scientist named Gupta, in 1986 by following 6 classes of sodicity. So in case of non-sodic water, the non-sodic water having the SAR value or the SCAR ratio, sorry, SAR to SCAR ratio is less than 5. Then normal water is having 5 to 10. Then low sodicity is 10 to 20. Then medium sodicity water is 20 to 30, and very high sodicity is having more than 40. Then alkalinity hazard, it is mainly calculated by residual sodium carbonate and residual sodium bicarbonate. Then or bicarbonates occur in a low salinity water and its concentration usually decrease with an increase in electrical conductivity. The proportion of bicarbonates ions is higher than calcium ions are considered undesirable because after the evaporation of irrigation water, bicarbonates ions tends to precipitate calcium ions. Hence the effect of the bicarbonates together with carbonates evaluated through RSC. Okay, RSC means, that means residual sodium carbonate. So formula for the residual sodium carbonate, that is carbonates plus bicarbonates minus calcium plus magnesium. This is the formula which are used for the residual sodium carbonate calculation. It is expressed in milli equivalent per liter of water. Then residual sodium carbonates. So these are the some value. If the residual sodium carbonate is less than 1.25, this water can be used safely. And then if it is between 1.25 to 2.25, water can be used with certain management. And if it is more than 2.5, it is unsuitable for irrigation purpose. Then magnesium is believed that one of the important qualitative criteria in judging the irrigation water is its magnesium content in relation to the total divalent cations. Since high magnesium content in relation to total divalent cations by soils affects their physical properties, a harmful effect on soil appears when calcium plus magnesium declines below 50. Then chlorides, the occurrence of chlorides ions in irrigation water increase with increase in EC and sodium ions. Therefore, these ions are most dominant in very high salinity water. Unlike sodium ions, the chloride ions neither affect on the physical properties of the soil nor are absorbed by the soil. Therefore, it is had generally not been included in modern classification because it does not having any effect. So that why it is not generally considered under modern classification system. However, it is used as a factor in some regional water classification. Then chloride concentration. If the chloride concentration, the value it is 4 milliequivalent per liter, it means it is excellent water. If it is between 7 to 10, the slightly usable, and if it is above or more than 20, it is not suitable for irrigation. Right from or above 12, it is not suitable for the irrigation purpose. Then sulfates. Sulfate salts are less harmful when compared to chlorides. This is because when both the ions occur in this concentration, only half of the sulfate ions contribute to salinity due to the fact that approximately half of the sulfates gets precipitated as calcium sulfate, while the other half remains in soluble form as sodium magnesium sulfates in the soil. That is the reason the potential salinity of irrigation is calculated as chloride plus half of sulfates. Okay, so Eaton proposed three classes for sulfates. That means if the value is between or less than 4 milliequivalent per liter, it is considered as excellent water. If the value is between 4 to 12 milliequivalent per liter, is good to injurious. While if the value is more than 12 milliequivalent, the water is considered to be injurious or maybe harmful for the irrigation. Then potassium salinity, it can be worked out by using the formula chloride plus half of sulfates, where ions are expressed in milliequivalent per liter. If the potential salinity is between 3 to 15, it is can be recommended for medium permeability soils, and if the value is between 3 to 7, it is recommended for the soils of low permeability. Then in case of a boron, it is evident that boron is essential for the normal growth of the plant, but the amount required is very small. It may be considered as a micronutrients or the for the or it is required in very little quantity. So there is a four class, that means very low, low, medium, and very high. If the classes that is very low, the crops mainly the sensitive crop is having the value below than or less than 0.33. Then if for the semi-tolerant crop, it is the value between 0.67, and if for the tolerant crop, the value of boron should be less than 1. Okay, so this is the for safely used, we are considering above the 3 or 2 to 3, it is unsuitable for the tolerant crop also. Then fluoride are only sparingly soluble and are in small amounts. The concentration of fluorides ranges from traces to more than 10 milligram per liter in natural water, and surface water do not exceed zero point 0.3 milligram per liter unless they are polluted. That means the fluoride contents are occur in very small amounts. Irrigation with fluoride saline water up to 25 milligram per liter has not been found to affect yield of wheat. So while we are considering, these are the some experiments which are carried out in past, there is therefore it is doubtful for if fluoride requires any monitoring in India. So that's why there is a no monitoring on the fluoride content or the fluoride content in the water. Then a nitrate, very frequently groundwater contains high amount of nitrate. Okay, so this nitrate, when such types of irrigation water is applied on soils continuously, various properties of soils that may be affected. If the nitrate value is uh, less than 5, it is having no problem. If it is between 5 to 30, intensity of problem is moderate, and if is above the 30, the intensity of problem is very high or a severe intensity. So in case of lithium, lithium is a trace element, may be found in most of saline groundwater and irrigator soils. It has been found that 0.05 to zero point 0.1 ppm of lithium in water produce toxic effects on growth of citrus. It has been also reported that saline soils of varying degrees found in India contain lithium up to 2.5 ppm. Fortunately, the germination of the majority of crops is not affected with this level of lithium content. So basically, in same in case as a case of fluoride, the concentration of lithium is not affected the majority, sorry, not affected with this level to the crops. So the management of practices for using poor quality water, that is application of gypsum, then alternate irrigation strategy, then fertilizer application, methods of irrigation, then crop tolerance, method of sowing or drainage. So other management practices mainly consist of overage seedlings in rice, then mulching, then soil management, then crop rotation, then crop tolerance. The crops differ in their tolerance to poor quality waters. Growing tolerant crops, when poor quality water is used for irrigation, helps to obtain reasonable crop yields. So the tolerant variety we are using for the to avoid the problems of irrigation water. And these are the some crops that is for the salinity. Tolerance mainly in field crops, that is cotton, sunflower, sugar beet, barley. Fruit crops, date palm, guava. Then in case of vegetable, that is turnip and spinach. Then forest crop, basil, rose and grass. While for the sensitive, in case of sensitive, field crop, that is chickpea, linseed, beans. And fruit crops, that is apple, orange, almond, peach and pear. Okay, so mainly those found which are in, which those crops which are found in the temperate region, that are sensitive for the soil salinity. So this is all about the parameters or the quality of irrigation water, or the parameters we are judging for the analysis of irrigation water. Thank you.